All right, going back through this so we can get to the proofs. Parallel lines, remember, we got all these different types corresponding on the same side of the transversal, same side of the parallel lines. How many different groups of corresponding do I have up there? How many?
2.
Nope.
1.
4. These two right here, the two underneath them, same thing on the other side. You got 4 different groups of corresponding. Consecutive, it can be interior or exterior. What is the deal with consecutive? What?
They gotta be in the same.
They're going to be on the same side, but there's something specific about consecutive that we're supposed to remember. They're not the same, but
They're the opposite.
They're not the same, but there's something with them that we're supposed to remember.
Parallel.
No.
They're exact opposite.
What would you mean by opposite?
Like that one over there, if you add both of them up, they equal to 180.
That's what I need. I don't care about opposite. Opposite doesn't mean anything. They add up to be 180. That's what we need. Corresponding, on the other hand, what do we know about corresponding? Those are equal. Corresponding is equal. Consecutive, whether it's interior or exterior, like the ones I just drew, those add up to be 180 because they're supplementary. That's what we need to remember. Alternate interior, alternate exterior. We should remember those, right? Interior is in between, exterior is on the outside. Those are equal to each other. All right, copy that down. All right, we're going to start with vertical angles, a proof about vertical angles. Now we know that vertical angles are the same, right? We're supposed to know that anyway. This is the proof of why they're the same. In a proof, the 2-column proof like we got right here, you're going to have a statement that you come up with and then a reason mathematically of why you're saying it. The first statement is always going to be your given. The last statement needs to be the proved part. All right. On this one, I want to prove that angle 1 is equal to, angle 1 is equal to angle 2. Well, we can't use because they're vertical because that's what we're trying to prove. Does that make sense? If I'm trying to prove vertical is congruent, I can't say they're congruent because of being vertical. All right, so we've got to do something else to show that they're the same. All right, I'm going to do this first one kind of for you. All right, we'll start by saying angle 1 plus angle 3 is equal to 180 and angle 2 plus angle 3 is equal to 180. Now, why can I say that?
Because
What do they make?
36 or 37. A line.
A line. So 1 plus 3 equals 180 and 2 plus 3 equals 180 because they're linear pairs. All right, well, if 1 plus 3 is equal to 180 and 2 plus 3 is equal to 180, what can I say about those? 1 plus 3 and 2 plus 3.
30.
They're equal to each other. If this thing right here is equal to 180 and this thing right here is equal to 180, what do I know about those two things right there? That they've got to be equal.
They're equal.
So I'm going to say angle 1 plus angle 3 is equal to angle 2 plus angle 3 by substitution. I'm taking out the 180 and substituting in the other stuff that's equal to it. What did I do to go from angle 1 plus angle 3 equals angle 2 plus angle 3 to angle 1 equals angle 2? What did I do?
You two got the 3.
The rule that I did is I just subtracted. If I subtract off the angle 3's, I'm left with angle 1 equals angle 2. There's a proof. All right, if I'm trying to prove that 3 and 4 are equal, what would I do next after saying that they are vertical?
It would be angle 3 plus angle 1 is 180.
Angle 3 plus angle 1 is 180. Angle 4 plus angle 1 is equal to 180. Do I have to use angle 1?
No.
You can use angle 2.
I could have used angle 2 right there and it would have been the same thing. The reason I can say that is because They're linear pairs. I know that they have to add up to be 180.
So 2 don't add up to be 180. 2 don't add up to be 180.
I could do 3 plus 2 and 4 plus 2 and it'd be the same exact thing.
Okay.
So just the one, you don't have to have the ones, but you do have to have the same thing right here for these two parts. So if you do 3 plus 2, then you got to do 4 plus 2. All right, and so if 3 plus 1 equals 180 and 4 plus 1 equals 180, then angle 3 plus angle 1 equals angle 4 plus angle 1 by substitution. And if I subtract off the ones,
Angle 3.
then angle 3 equals angle 4, which is what I was trying to prove.
That's cool. Now I got it.
So that's it.
If I want to prove 5 and 7 are vertical, I'm going to say that, well, 5 plus 6 or 8, which one do we want to do?
6.
All right, 5 plus angle 6 is equal to 180. Then I have to say angle 7 plus angle 6 is 180 by a linear pair. Again, what else could I have used beside the 6?
8.
I could have put the 8s in there and everything would have worked exactly the same. Angle 5 plus angle 6 is equal to angle 7 plus angle 6 by substitution. And 4 is angle 5 equals angle 7 by subtraction. It's going to be the same proof every time for that, for vertical angles. All right. This one, we're starting with parallel lines, A and B. I want to prove that angle 3 is equal to angle 6. What kind are angle 3 and angle 6?
Parallel lines.
Angle 3 and angle 6, what kind are they? What? Alternate interior. I know that alternate interior are congruent to each other. This is going to be proven how they are congruent to each other. And there's a few different ways. I'm going to start with one way and then we'll do another one later.
Both of them add up to 180.
All right. If I want to do 3 and 6, I could do the 180 route, but it's not the fastest. I'm going to go a little bit shorter route. Which one is angle 3 equal to besides angle 6?
Angle 2.
Because of what?
Because they're corresponding.
No. Vertical. So I'm going to say that angle 3 is equal to angle 2 because of vertical. And we just proved vertical was the same, so I'm good there. All right. Can I say that angle 2 is equal to angle 6?
Yes.
Yeah.
Why?
It's
Because
corresponding.
angle 3 is equal to angle 6.
Nah, because it's corresponding. I'm trying to prove that 3 and 6 are the same. So I've got to use other stuff besides alternate interior. Well, if angle 3 is equal to angle 2, and angle 2 is equal to angle 6, what does that mean?
Angle 3 is equal to angle 6.
Because of?
All that.
What did I do that?
You got me subtract. No, you said
I didn't subtract. I substituted. I substituted the 3 in the 2 spot, or the 6 in the 2 spot, and then I have my proof.
Sounds even easier.
Yeah, that was to me easier. So we did vertical and then we did corresponding. Well, could you do it the other way? Could you do corresponding first and then vertical second? Yeah. I could start by saying angle 3 is equal to angle 7 because of corresponding, and then angle 7 is equal to angle 6 because of vertical, and then angle 3 is equal to angle 6 because of substitution. So again, there's different ways of doing it. All right, that one's yours. All right, start with 2 is equal to 5 because of vertical, and then 5 is equal to 7 because of corresponding. Then that puts 2 is equal to 7 because of substitution. I could have done it the other way and said, all right, well, angle 2 is equal to angle 4 because of corresponding.
Angle 4
And
is
angle
equal to
4 is equal to
7.
angle 7 because of vertical.
this is easy.
Angle 2 is equal to angle 7 because of substitution. It's the same proof, just a different order. The deal with proofs, you have to go in a logical order and you have to have reasons, math reasons, for what you're doing. Should be able to do that one quick. See if we can get it before we get out of here. What do we want to start with? All right, so 4 and 1 are vertical. And then
Angle 5 is equal to angle 1.
angle 5 is equal to angle 1 because of corresponding. That means angle 4 is equal to angle 5 by substitution. All right, what did we start with? 3 plus 4 is 180 because it's linear. And then 4 is equal to 5 because of alternate interior. So then I can substitute and say 3 plus 5 is 180 by substitution.
4 and 6.
And then angle 3 and angle 5 are supplementary by definition of supplementary angles. All right, if I want to get 4 and 6 being supplementary, I'm going to start by getting them equal to 180 somehow. What can 4 be 180 with? Either 3 or 6. No.
No way.
3 or 2. It makes a line with 3 or 2. So I'm going to say 4 plus 3 is 180 by linear pair. And I know that 3 is equal to 6 because of alternate interior. And if 3 is equal to 6, I can substitute that out and say that 4 plus 6 is 180 by substitution, and finish it by saying, well, 4 and 6 are supplementary by the definition of supplementary angles. All right, what do we want to start with to do?
I did angles 1 and 8 are alternate exterior.
All right, so if I say angle 1 is equal to angle 8 by alternate exterior,
4 and 8 linear.
I could say 4 plus 8,
180.
4 plus 8, 180 because of linear.
Substitution. 1 plus
Angle 1 plus angle 4. By substitution. And then I can say, well, if 1 and 4 is equal to 180, angle 1 and angle 4 are supplementary by the definition of supplementary angles.
I've done like this.
5, 1, 5.